Yeah, welcome to the mathematics and a new video. Today I want to talk about interesting logarithm properties, and this is what we want. And before we start, I want to mention what I assume for this video. So I assume the basic properties for the log, like logarithm of a product is the sum of the logarithms, and the logarithm of a fraction is the difference of the logarithms. Okay? And yeah, what we want is, what if the product or the fraction is in the base? Is there some nice way to separate the base? So what we want is to write this expression in terms of log a to base x and log a to base y. And also maybe what if we have a power. So this is a generalization of this formula, of course. Yeah, and to do so I want to talk about the base of change. So before we start, not base of change, change of base. So change of base. Okay. So if we have a logarithm, let's say from a to some base b, then we can choose a new base c. And we have this expression, and we prove this. So, and I hope I do not mess up the notation. So yeah, let's start with, for example, b to the power d equals a. Okay, and by definition we have d is log a to base b. Okay, here, yeah, on both sides we apply log to base c. So therefore we get log c of b to the power d is log a to the power a to base c. Yeah, now we can bring up the d in front of the logarithm. This is one of the basic properties. So we have d times log b to base c equals log a to base c. But remember, d is here, and if we plug this in and we solve for d, we immediately get this expression. Okay? So solve for d, and this finishes off the proof for the change of base. Alright? Okay, so let's take this one. And first, a special case is we can write any logarithm x to base y as 1 over log y to base x. Okay, this is exactly what we will use. You see, the argument of the log, it becomes the base, and vice versa. And this rule should help, because here the base becomes the argument, and then we can apply our basic rule. So let's do this. So we have log AB, pardon, logarithm of a to base xy. We write this as 1 over logarithm x times y to base a. And now by our basic formula we have 1 over log x to base a plus log y to base a, and we want this expression in terms of base x and y. So here the base is a, so we want to change this, but again we use our special case, and then we get 1 over log a to base x plus 1 over log a to base y. And this is the first result for this. Yeah, and you can try this by yourself, and you see here the product, yeah, it becomes a quotient, then the quotient becomes a minus here and a minus there. So for our second result we have 1 over logarithm of a to base x minus 1 over logarithm of a to base y. Okay, so this is the second. Yeah, and for the third, like I said, this is a special case of this, and then we use an inductive argument. Okay, but we can also do it with our base of change, so you can try both ways. So here what we find is 1 over logarithm x to the power n to base a. Now the exponent, it can come out 1 over n times 1 over logarithm of x to base a, and now we use this rule again, and we find logarithm of a to base x over n. And this is the third result I want to show. Yeah, I hope you liked it. See you next time, and bye.